Hi everyone, this is Kanika, and in this video we are going to discuss a medium level LeetCode problem, which is remove nth node from end of list. So in this question you are given a head of a list and we need to remove nth node from end of list, and after removal of the node we need to return its head. For example, let's see in this test case, head is given to us and n is given as 2. That means we need to remove the second last node, and after removal our linked list will look like this, and we need to return the head. Let's see the next test case. In this test case, there is only single node and n is given as 1. We need to remove this node, and after removal, we are left with an empty array list. So we'll return an empty array list. Let's see next test case. In this test case, linked list is this and n is given as 1. That means we need to remove this node. And then after removal of the node, we need to return this. Alright, so let's discuss the approach. So this is the linked list given to us and n is given as 2. That means we need to remove this node. So what we can do is we will maintain a temporary node or a dummy node which will point to head initially. So this is our head, and along with this temp node we'll maintain two pointers, slow and fast. Alright, since we need to remove this node, that means we need to change the reference of this node. We need to remove this pointer and 3 should point to 5. So that means we need to get hold of this node first. So in order to get hold of this node, what we will do is we'll move fast pointer. So we'll move fast pointer n number of times. Since n is 2, that means we'll move fast pointer 2 times. So let's move fast pointer. Fast is moved 1 time, again fast is moved second time. So we have moved fast pointer 2 times. After moving fast n number of times, now we need to move slow and fast pointers together by 1 till fast is not null. So here fast is not null. Let's move both the pointers, slow pointer and fast pointer, by 1 together. Again we'll check is fast null or not. Fast is not null. Again we'll move slow and fast both by 1. Again we'll check fast is not null. Then again we'll move slow and fast by 1. Now this time fast is null. So we'll stop at this point. And now you can notice slow is pointing at the node whose reference needs to be changed. So from here we can easily change the reference of this node by pointing its next towards its next of next. Its next is this and its next is this. And we can easily say that its next of next is not null, because since our fast is pointing towards a not null node, right? So we can easily change its reference from here. Let's see another example. Let's see another example in which n is 3. That means we need to delete our first node, which is head. So in this case, if our head would be deleted, then we need to return the new head, which would be node 2, right? So we'll maintain our temp node, which will initially point towards head. We'll maintain slow pointer, fast pointer. We'll make fast pointer move by n number of times. So let's move fast pointer n time. 1 time, this is second time, and third time. And now we'll notice that our fast is at the last node. So what we have done in our previous test case was, after moving fast n times, we have moved both slow and fast pointers by 1 until fast was not null, right? So in this case, we cannot move our pointers further. So if our fast dot next is null, that means we need to delete our head node. So in this case, what we'll do is we'll change our head to head dot next, and we'll return this as a new head. Okay, so now let's quickly see what we have done till now. We have maintained two pointers, slow and fast, and we have moved fast n number of times. And after moving fast, we have moved both the pointers together until fast is not null. So why we are maintaining two pointers? This I have already told you, because we need to get hold of a node before the node which needs to be deleted. So in order to get hold of a node whose reference needs to be changed, we need to move first fast pointer n number of times so that we can achieve n gap between slow and fast. For example, consider this linked list, and here n was 2, and we have maintained temporary variables slow and fast. And when we have moved fast n number of times, let's move fast n time first, 1 and 2. So we have moved fast n times. A temp was pointing towards head. So after moving fast n times, you will notice that our slow pointer is n times behind our fast node. So slow pointer is 2 nodes behind our fast node. So when our fast will reach at the end, our slow will reach at the node whose reference needs to be changed. So that is the reason we are maintaining 2 pointers. So now let's move to the code. Okay, so let's see the code. This is the definition of list node class. It has val and it has next reference, and these are the constructors. And this is the method which we need to implement. Remove nth node from n. We are given a head and an integer n. Here n denotes of node which needs to be deleted from the end. So we are maintaining a count variable to keep track of our fast pointer or fast reference, because we need to move fast n number of times. So we have initialized count as 0, and we are maintaining our temporary node and slow and fast pointers. First we'll check if our head is null. If our head is null, we'll return null immediately. Otherwise, we'll create a temp node and we'll keep our slow and fast pointers at temp node. And we'll point temp dot next to head. That means if this is our linked list and this is our temp node, our temp will point to head. So in this step, temp is pointing towards head. Now we need to move fast n number of times. So we need to achieve a gap of n number of nodes. Our slow node should be n times behind fast. So this is what we have done. We are moving fast n number of times. So count was initially 0. In this step, we have initialized count as 0, and this loop will run while count is less than n. So if our n is 2, this loop will run 2 times. So we are moving fast by 1 in each iteration, and we are incrementing count. So if our slow is here and if n is 2, then our fast will move from here one time and here second time, so that our slow node is n number of nodes behind fast. So this is the reason why we are moving fast n number of times first. So this whole loop is to move fast pointers n number of times. After that, we'll check that if the node to be deleted is first node or not. That means if we need to delete head or not. So how will we check that? We'll check that if our fast dot next is null. For example, in this case, n is 3. We'll move fast pointer n number of times. So fast will come here, come here, come here, third time. Right. So in this case, our fast dot next is null. Well, that means we need to delete our first node, head node. So we'll move head by 1. And we'll not go into this else block and we'll return head immediately. So we'll return our new head in this case. So if this node needs to be deleted, our head should point to the node which is next to it. So in this case, we'll return our new head. And if our fast dot next is not null, we'll move into this else block. And in this else block, we'll move both slow and fast by 1 till fast dot next is not null. So we'll keep moving slow and fast both by 1 until fast dot next is not null. So after moving both slow and fast by 1, our slow will point towards the node whose reference needs to be changed, so we can easily change its reference at this point. And after that, we'll return head. So what is the time complexity? Since we are traversing all the nodes of linked list, so our time complexity would be big of n, where n is the number of nodes in linked list. And what is the space complexity? Since we are not using any extra space, so our space complexity would be big of 1. So I hope you have understood it. Thanks for watching. See you in the next video. Bye for now.